Well, this video is for Math 70, and the topic for this assignment is what's called absolute value. Okay, so absolute value is a, I don't know what to call it. It's a function, it's a definition of distance from zero. So if we look at 0 and we look at 3 and -3, this distance is 3, this distance is 3. So absolute value of 3 is 3, absolute value of -3 is also 3. That's what I'm saying, talking about distance from 0. Okay. Another way that this is defined algebraically so that people can work with this if we don't have a numerical value inside the absolute values. You can say the absolute value of x will be x if it's a positive number or 0, and it will be the opposite of x if it's a negative number. Now this is a little bit confusing because we know that the absolute value always turns out to be positive, so sometimes when people see this negative sign they're like, what's going on there? Well, that's only if x starts out negative, this will turn it back positive again, right? So the step I'm leaving out here is that one, and then there it is, positive 3. Okay, so that's the definition of absolute value. A simple way to think about it, it's always a positive number. Okay, so here's the thing. So let's look at some problems on the handout. Problem 2 says absolute value of x equals 7. So this is the key feature of an absolute value equation, is that you've got to split it into two pieces because there's two possibilities. X could be 7 or x could be -7. We get two solutions, right? Because absolute value of 7 is 7, absolute value of -7 is also 7. So that's the fundamental idea behind these problems. Let me look at number 6. And then we'll go back and talk about number 4. In number 6, this is really sort of the only one that's like this. We want to get the absolute value piece by itself first. So let's move that 5 to the other side. And then this actually just turns out to be the same as number 2, where we get x could be 7 or x could be -7. So there's our two solutions for number 6. Okay. Let's go back and talk about number 4. Problem 4 is a trick question. This one says absolute value of x equals -12. Well, so here's the thing. Because the absolute value denotes a distance from 0, these distances are always defined to be positive. Okay, so whether you're at 7, your distance there is 7, or you're over at -7, the distance there is also 7. Okay, we don't consider the direction you're going, we're only interested in the distance from 0. So this distance of -12 doesn't have a lot of meaning on this number line, and so this is one of those situations where we say no solution, because the absolute value is always positive. No matter what number I put in here, the answer comes out positive, so it'll never be equal to -12. Okay, so that's why we get a no solution on that one. All right, let's keep working. Let's see what else we have here. Let's do problem 10, and then we'll go back and do the one with the fraction. Problem 10, 3x minus 4 equals 20. Okay, so the absolute value is by itself, so we're all ready to start. So we want to split this in two pieces. So what's inside here could be 20, or it could be -20, right? Because if it's equal to -20, then the absolute value will be 20. So we've got two equations to solve here. Add 4 to both sides. 3x is 24, and so x is equal to 8. Over here, add 4 to both sides. Let's see here. Negative 20 plus 4, that's going to be negative 16. Divide on both sides by 3. Negative 16 thirds, or if you like decimals, negative 5.3 repeating. Okay? All right. Let's see here. So there's our two solutions, and this is the fundamental idea of absolute values, is that it gets split into two pieces. And I can tell you when I'm grading these problems on the exam, somebody who splits it into two pieces and then makes a mistake solving it, well, I'll just take off a little bit of points. But if you never split it into two pieces, then you're demonstrating to me that you really don't understand how absolute value works, and I'll take off the majority of points on that problem. Okay, problem 8. This is the one with the fraction here. Absolute value x plus 2 equals 7 over 5. So again, the absolute value is by itself. All we have to do is split it in two pieces. So we could say x plus 2 equals 7/5, or x plus 2 could be negative 7/5, because then when we take its absolute value, we'll get that 7/5 back. All right, so let's see. We're going to subtract 2 on both sides. This is 10/5, so 7 minus 10 is negative 3/5. If you like decimals, you can do this all as decimals, and it would be negative 0.6. All right, let's subtract 2 again. Over here, negative 7 minus that 10/5, right? Then that's going to be negative 17 over 5. And again, if you like decimals, what's that going to be there? Negative 3.4. So there's our two solutions for problem 8. All right, let's see. Let's look at a few more of these. Okay, let's see here. Problem 12. We've got absolute value 4/5 x minus 5 equals 15. Okay, so the absolute value is by itself. We'll split this in two pieces. 4/5 x minus 5 is 15, or 4/5 x minus 5 could be negative 15. All right, let's add 5. So that'll be 20 equals 4/5 x. And you can divide on both sides by 4/5. If you have a calculator, then doing 20 divided by 4/5 is a way that I see most students solving this. I learned to do this before calculators were around. Plus, it's faster for me to do it this way. And so we get x equals 25. 20 divided by 4/5 should give you 25. All right, let's solve this one. Let's see here. 4/5 x equals negative 10. So again, let's multiply on both sides by 5/4. And this all cancels out. And what do we get here? Negative 25 over 2, or negative 12.5. So there's our two solutions. Let's see what else we've got here. Problem 14. Absolute value x plus 8 equals negative 3. Okay, now, before I start solving this one, notice we've got an absolute value equal to a negative number. That can't happen, okay? The absolute values always come out to be positive, so you have to recognize when it's being set equal to a negative number, okay? In that case, we just say no solution. Okay, let's see what else we've got here. Problem 16. absolute value, 12x minus 7 equals 43. Okay, no problems. So the absolute value is by itself. So let's split it into two pieces. Could be negative 43. So add 7 over here. 12x equals 50. And then divide on both sides by 12. What is this? 25 over 6. So that's going to be, if you like decimals, this one's going to be 4.16 repeating. That's 4 1/6. Okay, so that's one solution. And over here, we'll add the 7. 12x is going to be, what, negative 36. And then divide on both sides by 12. X would be negative 3. Okay, let's see what else we get here. Well, let's look at problem 20. We've got absolute value 5x minus 1 equal to 21. So, split it into two pieces. Negative 21. And now we solve these two equations. Add the 1 to both sides. 5x would be 22. And x is 22 over 5. And there's no need to change it. You can call it 22 over 5. That's fine. If you like decimals, what's that going to be? I think it's going to be 4.4. Okay, here. Add 1 to both sides. That'll make negative 20. Divide on both sides by 5. And x could be negative 4. All right, let's look at one more here. Excuse me, problem 22. Absolute value 2x minus 9 equal to 18. All right, so let's go ahead and split this into two pieces. 2x minus 9 is 18, or 2x minus 9 could be negative 18. All right, so let's add 9 to both sides. So 2x would be 27, and then we divide on both sides by 2, and we'll get 13.5, or you can just call it 27 over 2. Here, add 9 on both sides. 2x is negative 9. Divide on both sides by 2. X is negative 4.5. Okay, so that's it for this handout on absolute value equations. Let's see, I think that's going to be it for this week. And then when we get into next week, we'll have a series of assignments on graphing, and then we'll stop and take our midterm during week 5. So, as always, if you have any questions about these, please let me know. Thanks.